Hi, I will give you explanation about introduction of vector. A vector is a physical quantity that has both a magnitude and direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of the vector is from its tail to its head. And now, I will explain to you about introduction of scalar. A scalar, a physical quantity that is completely described by its magnitude. Example of scalar are volume, density, speed, energy, mass, and time. Other quantities, such as force and velocity, have both magnitude and direction and are called vectors. How about the difference between vector and scalar? Let me explain to you. Scalar quantity is different from a vector quantity in terms of direction. Scalar don't have direction whereas a vector has. Due to this feature, the scalar quantity can be said to be represented in one dimension whereas a vector quantity can be multidimensional. From the table given below, let us learn more difference between scalar and vector. So, this is a table about difference between vector and scalar. I will give the characteristic about vector and scalar. Scalar, it has only the magnitude, only one dimensional. This quantity change with the change in magnitude. Normal rules of algebra are applicable here. One scalar quantity can divide another scalar. In the example of speed, time, the distance between the point is a scalar quantity, not the direction. While vector, it has direction and magnitude. It is multidimensional. This change with magnitude and direction. There is a different set of rules known as vector algebra. One vector cannot divide another vector. Velocity could be an example because it is a measurement of the rate of change of an object's position. Application of vector and scalar. Vector and scalar are necessity and widely used in our daily life. It is used in many aspects which involve physics in life, such as engineering, architecture, geography, and navigation. It is also has been used to visualize displacement, velocity, acceleration, projectile motion, military usage, vector in gaming, roller coaster, crosswind, and many more. In this topic, we use vector and scalar to find the angle of building and area of its surface.
Formula and application: scalar dot product of vector. The scalar product or dot product of two vector A equal A1 x plus A2y plus A3z and B equal B1 x plus B2y plus B3z is defined as follows. Formula in component: A dot B equal A1 B1 plus A2 B2 plus A3 B3. Formula in geometrically: A dot B equal magnitude A magnitude B cos theta.
Given two linear ellipse, independent vector A and B, the cross product A multiplying B is a vector that's perpendicular, orthogonal to both A and B, and vectors normal to the plane containing them. The cross product is defined by formula. Define it. Example, scalar cross product of vector A and vector B that is equal to ijk A1 A2 A3 B1 B2 B3. So is equal to, remember, plus minus. You get A2 A3 B2 B3 I minus A1 A3 B1 B3 J plus A1 A2 B1 B2 K, and then you cross multiply, you will get A1 times A2 A3 times B2 I minus A1 times B3 minus A2 times B1 J plus A1 times B2 minus A2 times B1 K.
Okay, for the next question, how to find area of a surface? Let's say vector A equals to 4i minus j plus 2k, and vector B equals to 2i plus 4j minus 3k. Okay, for this question, we use vector dot product. Vector dot product, like we solve equation for matrix. Vector A cross vector B equals to I for 2, j negative 1 for k 2 negative 3. Vector A cross vector B equals to negative 1 2 4 negative 3 I minus 4 2 2 negative 3 j plus 4 negative 1 2 4 k. Vector A cross vector B equals to negative 1 times negative 3 minus 2 times 4 I minus 4 times 3 negative 3 minus 2 times 2j plus 4 times 4 minus negative 1 times 2k. So we get vector A cross vector B equals to negative 5i plus 16j plus 18k. After that, we find the magnitude of vector A cross vector B. Vector A cross vector B magnitude equals to negative 5 square plus 16 square plus 18 square. So we get 16,605, and we get 24.6 units square.
So the conclusion is vector and scalar are utilized in day-to-day life to assist in the localization of people, place and things. A quantity that possesses both a magnitude and a direction is known as a vector, while scalar is a quantity that possesses magnitude only. We use both vector and scalar quantities daily in our life without us knowing we do. Some technologies apply vector and scalar in order to make it happen. Without it, our life would be lacking because vector and scalar have contributed a lot in making life better.